Unit 2, Population, Key Issue 2, Content Objective. Where and why has the world's population increased while using human geographical measurements? The I-CAN statements for this content objective, again, aligns to Key Issue 2 in your text. Explain how arithmetic, physiological, and agricultural densities are used to describe population distribution. 2. Define how one measures population growth through the natural increase rate, NIR. 3. Explain how to measure births and deaths through CBR and CDR. Also, calculate CBR, CDR, and NIR rates for the regions of the world. 4. Explain how population measures can determine the role of a woman. Explain the impact of guest workers on European population trends. And then 6, using population momentum, NIR, and doubling time, describe where and why the population is increasing. Population densities. Remember back to Unit 1. Arithmetic density is taking the number of objects and divided by the land area. In this case, we're taking the number of people divided by land area. Physiological density is taking the number of people per arable land. Arable land is land you can farm on and grow crops. And then you divide that, so you divide population by arable land. Agricultural density is the third form of density when we look at population. That's going to be taking the number of farmers per arable land and dividing it by land area. So dividing the number of farmers divided by arable land. Which of these densities is the most important in understanding overpopulation? Physiological density, and we'll explain it throughout this unit, because physiological density, humans depend on human survival needs such as water, food, shelter. There's basic human geographical needs: water, shelter, food, and oxygen. All right, let's take a look at the arithmetic density, and the highest arithmetic densities are found in the clusters of the world, as we already mentioned. The highest arithmetic density we see is in South Asia. We can also see a high arithmetic density in parts of Europe, Germany, and Eastern Europe. And we can also see population densities that are fairly high in the Western Hemisphere, being Central America. The lowest population densities, or arithmetic densities, are in North America, as well as South America, and then also South Pacific, Australia and New Zealand. And also Eurasia, Russian Federation. We can take a look in regional variation. We look at the country of Tanzania, as well as Kenya and Uganda. We can see that there's a high arithmetic density around the Great River Valley. This shows us within those countries they'll have the highest population concentrations and highest arithmetic densities. When we look at comparing densities of countries, we can see that for your test, you're going to have to be able to calculate density and be able to read tables like this. When we look at the overall crude density, that's the arithmetic density, we can see that the most people per land anywhere in the world is Bangladesh. And the second is in India. But in Bangladesh, it has 3 times as many people per square foot or square mile of land than in India. And the country that has the least amount of people per square mile is Australia. And then if we look at the physiological density, this helps us understand if people have access to human geographical basic needs. We can see that Bangladesh has an extremely high physiological density, so we can base that extremely high physiological density tells us that they have 3,000 people, 3,776 people per square area of land, but nearly double that per arable land, meaning there's not much food to meet the need of the people, meaning that people are going without access to proper nutrition or food. We can also see that there's high rates in Egypt, and Egypt also tells us that they have a very little arable land per person. So same with Japan. But we have to dig a little bit deeper and look at agricultural density. We can see looking back at Bangladesh, is that yes, the population is in dire need. There's a large portion of the population that doesn't have access to basic nutrients. We can see because the agricultural land, the number of farmers per land are 3,573, meaning that they have very inefficient farming. They mostly farm by hand, and there's not a lot of land to farm. If we look at Egypt, the agriculture density, they have a little bit more technology. They have a little bit more land to farm. Their farm sizes are slightly bigger than that of Bangladesh, but still access to proper nutrients is an issue in Egypt. If we look at Japan, they have very efficient farming. They don't have many farmers per square foot of land, so they have efficient farming, meaning that farmers can produce enough to meet the needs of their people. All right, physiological densities, we can see where they're the highest, and we already talked about the concerns of Egypt, being people that are Egyptian, that live in the country of Egypt, will have hardships finding proper nutrition. Also, we can see in the country of Colombia in South America, and we can also see high physiological densities in Japan, but we know that they have efficient farming, so they're not going to have many malnourished or large populations that are in lack of proper nutrition. All right, again, looking at population densities, we can see Canada has low agricultural density, low arithmetic density, low physiological density, meaning that they have, everyone in Canada, they have very few people that are malnourished or undernourished. We can take a look at all the countries on the list except for Egypt is a country that's struggling to meet all the needs of Egyptians in their proper nutrition. And again, let's take a look at arable land, agricultural density. We can see inefficient farming wherever it's dark green. So most of the people are going to be intensive farmers, meaning they're going to be farmers that work on a small plot of land, and they're going to use their hands, and they're not going to be able to produce much, for surely not produce surplus. Then anywhere where it's light in color, they're going to have efficient farming. Mostly it's going to be mechanization, very little hand farming labor, and they're probably going to produce enough for surplus. Components of population growth. We look at CBR. Crude birth rate is the total number of live births per year out of 1,000 people. If a CBR of 20 means that every 1,000 people in a country, 20 babies are born in 1 year. And then you take that 1,000 and divide it by the total population of that country, and it'll tell you exactly how many births in that year. CDR is the same. It's the total number of deaths per year out of 1,000 people. So let's say there's 10. 10 would be the number of deaths per 1,000, and then take the total population of that country and divide it by that number. And natural increase rate, it is the percentage, so it's out of 100. It is computed by subtracting the CDR from the CBR. And so if CBR is 20 and CDR is 10, then we know the natural increase rate is 1%, or 10 per 1,000 people. The natural increase of the world was 1.2 in 2019, which means that the population of the world has been growing about 1.2 percentage, which is lower than the all-time natural increase rate, which was 2.2 in 1960s. If you have time, this is a great video. Okay, and the answer we didn't talk about in that last notes, but in the answer, what it tells you is if you have let's say 7.5 billion people, and you divide by 100, and the natural increase rate is 1.2. It'll take roughly, they'll add roughly 90 million people this year. So again, we add about 90 million people to the world this year. We can look over time and we can see the exponential growth of population in the last 100 years. Really just stagnant, very small growth up until the Industrial Revolution that takes place in Europe in the 1750s. But really we begin to see when now the United States becomes industrialized in the 1800s to 1850s, and now population grows. And then by 1950s, industrialization, countries will industrialize all around the world. All right, so we add about 90 to 95 million people a year, which is the world annual natural increase rate. The doubling time is going to be the years needed to double the population. So we're assuming, let's assume in the 21st century, the natural increase rate remains at 1.2%. That means it'll take 54 years to double the current population of 7.6 billion people. The global population in 2010 could reach up to 24 billion people. Could reach. Again, these are projections. There's no guarantee that it's going to be 24 billion people. In 63, I already mentioned, was the highest natural increase rate. And then by the global population in 2010, we reached, there was projected to reach 10 billion, and by 2010 we reached just 7 billion. Remember, more than 95% of the growth is in developing countries. We can see the natural increase rate in these developing countries. Sub-Saharan Africa, that's the least developed region of the world, and then parts that are developed in Southwest Asia, and South Asia, Central Asia, and then Central America and parts of South America. They're going to have the highest natural increase rates. All right, the majority of the population growth in the developing world, 31% comes from South Asia. Remember the countries we mentioned: India, Pakistan, Bangladesh, the three large countries, three large populations in terms of the numbers of countries. And then East Asia, with the largest country being China, but also take into account Japan and Korea's. And where's the fastest natural increase rate? It would be Africa, Sub-Saharan Africa. And Sub-Saharan Africa, I believe, is cut off here. Sub-Saharan Africa should be the 20%. All right, so the doubling time as follows. If you have 0.5 natural increase rate, then the doubling time will be 140 years. 1% natural increase rate, 70 years. We also look at the measurement of total fertility rate. This is the number of children, the average number of children a woman in childbearing years, 15 to 49, will bear during her lifetime. The total fertility rate of the world is 2.5. Total fertility rate is highest in Sub-Saharan Africa, meaning that the average number of women in her childbearing years in Sub-Saharan Africa will have 5 children, whereas in more developed countries, such as Europe, women will have well less than 2. Same with the United States. Another measurement we look at for measuring population increase or decrease is infant mortality rate. Infant mortality rate is the number of deaths of infants under the age of 1 out of 1,000. So if an infant mortality rate is 5 in developed countries, that means 5 out of every 1,000 children that are born before the age of 1 perish. And they are the lowest rates, so it shows low natural increase rate. And then we look at Sub-Saharan Africa, that has the highest infant mortality rate. Nearly 8 out of every 1,000 births perish. We can take a look at the total fertility chart, and we can look at birth rates and death rates, and we can see that again, we can see birth rates. There's going to be in more developed countries less births per thousand because women are having the total fertility rate is lower. Where we see rates higher like Egypt and Nigeria, total fertility rate will be higher because there are more births per thousand. Population increase. Throughout the 20th century, we saw an explosion in MDCs in the turn of the 20th century, so the 1900s. Total fertility rate fell below, or in the 21st century, total fertility rate fell below replacement level. For a country to replace the current population, it needs to be at 2.1% natural increase rate. Total fertility rate in the 21st century had dipped well below 2.1, where now you hear the saying Europe is vanishing. They have a high elderly dependency ratio, and we'll talk about that with population pyramids, meaning that a large percentage of people are dependent on the labor force and taxes. And then adopting pronatalists, so pronatalists are encouraging women to have more children. We see policies with policies in many parts of the world with European countries, but also the reasons why we see those is because of guest workers, those that come from neighboring countries to fill the vacancy in jobs. And then they also have generous government subsidies for having children, such as like in Japan. They'll also recruit native Japanese to come back to Japan. Those are pro-natalist policies. And then they might have immigrant policies that limit immigrants into the country. And guest workers would be immigrants that come usually for low-skilled jobs from less developed regions to work in more developed countries for a lower wage. But immigrant policies would, again, limit the number of immigrants in a country and thus encouraging more births per woman, a higher total fertility rate. Population momentum is another key term that in a country like China experiences population momentum. Their population is so large that even though their CBR is going down, their natural increase rate's going down, they're still growing because they have such a large population. Their population still grows. That's called population momentum. This is also common in Singapore. We see it because the rapidly aging population in some of these regions, also the strain on social services. All right, guest worker flows. Again, we see the guest worker flows coming from less developed regions that are close to Europe, from Southwest Asia and North Africa, coming into Europe because of the lack of people, laborers to fill those jobs. And then guest workers, as you'll learn, they were banned in the 1980s. Why is global population increasing? Well, U.S. population will grow 20% between 2017 and 2050. It's mostly due to immigrants. China, Japan, and Europe will decline. Europe is in DTM stage 4 or possibly 5, and we'll talk about DTM stages here today. And then also China has an anti-natalist policy, so to control population. Africa will continue to grow, and there'll be more than half the world's population growth between 2017 and 2050, as you can see in the bar chart below. India will surpass China, as already mentioned, between this year and 2025. All right, crude birth rate. highest in sub-Saharan Africa. Childbearing years, when young girls have children, highest in sub-Saharan Africa and in parts of South Asia, parts of Southeast Asia, and parts of Southwest Asia, and parts of South America. We can also look at the natural increase rate. The world population continues to grow. The annual population increase, even with a declining natural increase rate, as we can see, we're still increasing about 85 to 95 million people per year. All right, let's take a look at this table, and we can see when we look at this table what countries would be found in sub-Saharan Africa. If you again looked at country 3, that would be sub-Saharan Africa. What countries would be Western and Northern Europe? Those would be the lowest natural increase rate, 6.1. Or I'm sorry, not 6.1. I got to look at the birth rate. Sorry, the birth rate 9.7 is the birth rate, and there would be a higher accrued death rate with 13.5. So country 1 would be Western and Northern Europe. What about Latin America? Latin America would be represented by country 5, a natural increase or CBR of 19.7 and a death rate of 6.6. All right, in summary, here are the patterns we see. Developing countries are as follows: Europe, North America, Japan, Australia, Oceania. They have low natural increase rates, CBR, total fertility rates, TFR, and IMR. Meanwhile, the opposite holds true for developing countries. Which region has the highest NIR, CBR, CDR, infant mortality, independence rates? Answer is B. Which region has the lowest NIR, CDR, CBR, IMR? On this table, answer is D, Japan. What region will have more economic development? What regions will be the least economic? What region will be the most economically developed? That'd be A or E would be acceptable answers. And what regions will be the least economically developed? That would be C and B. Here's the accrued death rate.